A LoRaWAN site survey is a critical step in planning and deploying a reliable, long-range, low-power wireless network. The purpose of this video is to guide field technicians, network engineers, and system integrators through the systematic assessment of a physical location to determine the optimal placement of LoRaWAN gateways and end devices. Elements of a site survey include assessment of LoRaWAN wireless signal coverage, quality, and reliability in a specific location or area. Collection of data on signal strength, noise levels, and connectivity to ensure that LoRaWAN sensors can communicate effectively with the network. And determination of optimal locations for placing gateways and end devices. The steps of a site survey should be to determine LoRaWAN architecture and gateway roles. Determine appropriate placement of sensors. Determine appropriate number and placement of gateways. Measure signal quality. Review results and adjust placements as needed. Resurvey as needed, and create the final report. As a quick refresher, LoRa stands for Low Power Wide Area Communications. It is a low-bandwidth message-based protocol offering long range, with coverage up to 10 miles in rural areas and 2 to 4 miles in urban environments. LoRaWAN also offers low power usage, with battery life of end devices exceeding 10 years in some cases. AES 128 encryption is supported at both network and application layers. Finally, LoRaWAN offers high network capacity, with individual gateways supporting thousands of sensors. The first step in preparing for a LoRaWAN site survey is to clearly understand the use cases for the deployment. This involves identifying the types of sensors that will be used. Typical sensor categories include water and leak detection sensors, temperature and humidity sensors, movement or tilt sensors, door and window activity sensors, power monitoring sensors, any additional or specialized sensors required for the application. It is also essential to understand the physical environment where the sensors will be installed. This includes identifying whether the deployment will occur in indoor or outdoor settings. Indoor environments may include office spaces, warehouses, manufacturing facilities, retail locations, residential buildings, and parking garages. Outdoor environments may include agricultural fields or farms, utility infrastructure sites, and transportation and logistics areas. When planning the survey, gather details about each site. This includes the number of locations that will be included in the deployment. If multiple locations are involved, consider the possibility of using several sensors at each site. The complete address of each site, including floor and suite numbers, if applicable. The designated site contact person who can provide access and answer location-specific questions. And the preferred day and time for conducting the site survey. Expectation setting with the site contact is a critical part of preparation. This includes communicating the estimated time required to complete the survey, confirming physical access to necessary areas within the building or facility, and identifying any known limitations, exceptions, or restrictions that could affect the survey process. Ensure that all necessary equipment is available and functional before conducting the site survey. This includes a floor plan with details about where coverage is expected and types of sensors to be used. It also includes a PC with an internet browser. You will need a LoRaWAN gateway suitable for the intended deployment environments. You will need one or more radio bridge RBS304 single push-button sensors, including the corresponding keys required to activate the sensor, along with appropriate batteries for the sensors. Prior to the survey, open at least one sensor to verify the correct battery type, either two CR2450 batteries or a single CR2 battery. An AC extension cord and a cube tap to power equipment when outlets are not conveniently located is something else to bring along, as well as an Ethernet cable for a connection to the PC. You may want to bring an antenna extension cable if you can't place the gateway in an ideal spot. Use an SMA extension cable with the correct connector types. This may include male connectors, female connectors, reverse polarity, or non-RP connectors, depending on the antenna and gateway used. You may even want to bring a high-gain antenna if you anticipate weak RF signal or significant interference. Bring a set of basic tools that may be required for mounting, securing, or adjusting equipment during the survey. These include duct tape to avoid tripping and falling risks. Use duct tape to securing power or antenna cables to the floor. Painter's tape. Use blue painter's tape to temporarily secure the gateway or other equipment. This will reduce the chances of damage to furniture or walls. Tie wraps. You may need to secure cables to poles or desk during the site survey. Screwdriver. Used to remove and install sensor batteries. Pliers and wire cutters. Used to secure and remove tie wraps. Watch for timekeeping while conducting the survey. Bring multiple printed copies of the floor plan or location log. The floor plan should accurately reflect the survey area and include floor numbers, room numbers, or other identifiers. Before beginning the survey, confirm with the customer whether each location has visible signage or identification. This ensures you can reliably match your observations with the corresponding entries in your log. Use an accurate and synchronized time source to log timestamps during the survey. This helps correlate button press events or gateway logs with physical locations and activities. Begin the equipment preparation step by commissioning the gateway before conducting any sensor tests. See the separate MultiTech gateway commissioning document for instructions. Prepare the sensors before beginning any field testing. Ensure you have the correct device EUI, app EUI, join EUI, and app key for the sensor you are using. Install new batteries in each radio bridge push-button sensor. Verify the battery type is correct. Typically 2 CR2450 cells or a single CR2, as confirmed during earlier preparation. Once batteries are installed, add each sensor to the gateway. Navigate to LoRaWAN Key Management, add new local end-device credentials, and input the sensor's EUI and key information. To verify communication, press the push button on the sensor once. Go to LoRaWAN Packets in the gateway interface. Confirm that join request, join accept, uplink, and downlink packet types associated with the sensor's device EUI are listed with the current timestamp. Successful receipt of these packets confirms that the sensor is properly joined and communicating with the network. If you do not see these packets, one of several problems might be occurring. The sensor battery is dead. The distance between the sensor and the gateway is too small. Move the sensor about 15 to 20 feet away from the gateway and press the button again. If you see a join request, but no accept, the keys may have been entered wrong. The LoRaWAN network settings may be incorrect. Ensure the packet forwarder and network server are both running. Ensure the channel plan is appropriate for the region, US 915 for US, EU 868 for EU, and the frequency subband is 1 for US. LoRaWAN sensors contain firmware with specific settings that govern their behavior and reporting. Most sensors can have their behavior modified by sending a hex code message to them through the gateway. Specifically, the RBS304-1 push button can be optimized for use in a LoRaWAN site survey in the following ways. The sensor can be configured to send a message when the button is pressed and a separate message when it is released. It can also send a message reporting how long the button was held. The LED can be configured to flash on press, send, and when an acknowledge message, ACK, is received from the gateway. This last feature is what we will use to perform the site survey. We will modify the settings of the sensor so that when user is walking through a site or presses the button, they will watch for a series of LED flashes. 1 to indicate a button press, 2 flashes to indicate a button release, and shortly afterward, for rapid flashes indicated the message was received by the gateway, and the gateway responded with an acknowledgement. As long as you see the rapid flashing of the button LED, you're within range of the gateway, and when a sensor is installed in this area, it can be expected to work. To configure the sensor to use the settings we want, we will push a general downlink configuration to the sensor to set the baseline behavior. This downlink configures the following parameters. Supervisory, or keep alive, period is set to 12 hours. Adaptive data rate is enabled. Confirm messages are used. The number of uplink retries is set to 3. To apply this configuration, navigate to LoRaWAN, downlink queue in the gateway interface. Click Add New. Ensure that the correct dev EUI is selected for the push-button sensor you're configuring. In the data field, enter the hex value 01000C0C01. Set ACK attempts to 2. Set RX window to 2. Click OK to queue the downlink. While on the downlink queue screen, press the push button on the sensor to prompt it to receive the downlink. Click the refresh button every few seconds to monitor the status. Confirm that the queued packet has been sent to the sensor and is no longer pending. We're going to push a second downlink to configure the sensor for visual LED feedback. This configuration is particularly useful for verification, as it provides a visual indicator when the gateway acknowledges a transmission. The settings applied in this step are: enable button pressed event, disable button released and button hold event, hold delay of 0.5 seconds, enable LED illumination during button press, blink LED after send, and blink LED after message ACK received. Return to the LoRaWAN downlink queue menu. Click Add New. Confirm the correct dev EUI for each push-button sensor. In the data field, enter the hex value 060602. Set ACK attempts to 2. Set RX window to 2. Click OK. As before, on the downlink queue screen, press the push button on the sensor to prompt it to receive the downlink. Click the refresh button every few seconds to monitor the status. Continue clicking the refresh button every few seconds until the queued packet is sent to the sensor and disappears from the list. Finally, confirm that the sensor is behaving as expected. Press the push button on the sensor once and observe the LED. The LED should light up once when the button is pressed. It should flash twice, indicating the message was sent to the gateway. After a brief pause, the LED should flash rapidly 4 times, indicating the gateway received and acknowledged the message successfully. This confirms both proper configuration and reliable communication between the sensor and the LoRaWAN gateway. After pressing the button several times and confirming the LED behavior, return to the LoRaWAN packet screen on the gateway. When reviewing data in the packets menu of the gateway interface, several key fields provide insight into sensor communication and signal quality. Understanding these fields is essential for verifying successful transmission and diagnosing potential issues. Each entry in the packets menu includes a device EUI, which is the unique identifier assigned to each sensor. This value is used to track packets associated with a specific device. The SNR value represents the signal-to-noise ratio of the received packet. It is a measure of signal clarity relative to background noise. As a general rule, the SNR should be greater than -5 for reliable communication. A higher SNR indicates better signal quality. The RSSI shows the strength of the received signal. It is measured in negative dBm, and values higher than -110 dBm typically indicate acceptable signal strength. Values much lower than -110 dBm may lead to unreliable transmissions. UPCNF indicates an uplink confirmed message sent from the sensor to the gateway. These entries will typically include SNR and RSSI values, helping assess the quality of the received signal. The transmit receive time field shows the exact time the packet was either transmitted or received. This is useful for matching button press events to specific packets and verifying timing accuracy. Note that the packets menu does not automatically update. To view the most recent packets, you must manually click the refresh button. Regularly refreshing the screen during testing ensures that the most up-to-date information is displayed. At the start of the site visit, meet with the designated point of contact to review the plan for the survey. During this discussion, confirm the overall survey procedure and timeline. Identify any off-limits areas or sensitive groups of people that should be avoided during the survey. Next, position the LoRaWAN gateway as close as possible to its proposed permanent installation location. When selecting the location, ensure there is a nearby power source available. There is a suitable spot for placing the PC or laptop used to monitor the gateway during the survey. Once positioned, connect an Ethernet cable between the gateway and the PC. Power on the gateway. Check that the gateway's time is still accurate. If needed, reset the time under Setup, Time Configuration. After confirming the gateway is operational, test the sensors to verify they are reporting correctly to the gateway. Navigate to LoRaWAN packets to monitor traffic. Prepare for the survey by bringing multiple copies of the floor plan and or location log. This ensures that you can conduct multiple passes if necessary and properly annotate your observations. Proceed to each area or room where sensors are to be installed. At each location, hold the push-button sensor as close as possible to the proposed permanent installation location. This may be under a sink, toilet, door frame, or other relevant location. Press the push button only once. Avoid multiple presses, as this can generate unnecessary packets and complicate the data log. Observe the sensor's LED behavior. 1 flash when the button is pressed. 2 flashes when the button is released. 4 rapid flashes afterward, which indicate that the gateway successfully acknowledged the packet. Be aware that this may not happen immediately as you move further from the gateway. Wait up to 10 seconds for an acknowledgement message. If you do not receive one, you have moved outside the coverage range for the gateway. Be sure to clearly note such occurrences on your log or floor plan. Record the time of the button press on your floor plan or log sheet for each location. Continue to the next location and repeat the process. After surveying a few locations, check the packets menu on the gateway to ensure that packets from the sensors are arriving as expected. After all sensor locations have been tested, you will create a file with records for each packet captured. This file will serve as the record of the sensor activity and coverage quality during the survey. Return to the gateway interface. Go to LoRaWAN Packets. Click the Refresh button, then click the JSON link to download the captured packet data. Save the file using a name that includes the date and survey location, such as 2025-06-13_warehouse1.json. After the survey is complete, use the JSON to CSV converter program provided by MultiTech to convert the raw JSON file to a file that can be reviewed in a spreadsheet or database program. The converter program will strip unneeded data from the JSON file and add valuable fields, including a signal quality field that is created as the file is being converted. The field will be populated with the word poor if the SNR is lower than -18 or the RSSI is lower than -119. Once the file is converted, use a spreadsheet or database program to import and analyze the data. Fill in the location, room, or area data for the records with low signal strength. Do this by matching the timestamps in your log to the recorded timestamps in the data file. You can optionally add location information for all the other records, but your focus should be determining if there are any areas with poor signal strength. If there are not, congratulations. You don't need to investigate further. If there are areas that have marginal signal, you may want to test those areas again to ensure they don't get worse during a second survey. If you do have records with poor signal, try to determine why. Are those locations the furthest distance from the gateway? Are they on a different floor? Is there something blocking or interfering with the signal? Could it be a temporary or seasonal issue? Foliage in the summer? Construction equipment? Can this condition be corrected? After you have identified areas of poor signal strength, try moving the gateway or antenna. Place it higher if possible to get above sources of interference, or move it to a new location, perhaps closer to the locations with poor signal. If you move the gateway, you will need to conduct the whole survey again to ensure that the problem was corrected and new signal problems have not been introduced to areas where signal was previously good. You may find that it is not possible for one gateway to pick up all sensor transmissions. In that case, 2 or more gateways will be required for complete coverage. In this case, extra gateways will need to be configured as packet forwarders to deliver LoRaWAN packets to the LoRaWAN network server. Please contact MultiTech support for help configuring the gateway as packet forwarder. We hope you have found this presentation helpful as you roll out LoRaWAN networks. Should you have any questions, please contact MultiTech support. Thanks for watching.